Hey everybody, welcome to the Algebra 2 Module 4 Topic 1 test review. This is the first one I've done in a while. I've been just recycling old videos. Some parts have been different. I'm going to be like, hey, so yeah, you can watch my video, but the question 1 and 4 and 8 isn't really on there, so you can ask me. Well, guess what? We're starting fresh. We're doing a new topic that I haven't made a video on before, and maybe it's going to be kind of nice. So I'm going to walk through about half of this review. I'll probably choose one or two problems to do in each, on each page, a couple of each, and let you do the rest. And yeah, this one's all about trig functions, graphing trig functions, the values of trig functions, and most importantly, the unit circle, which is really what everything is based around. And in fact, on question 1 and 2, they have us label some points on the unit circle by writing the degree measurement, the coordinate point, and the angle that it makes on the edge of the unit circle in terms of the radians. And it says to use your unit circle as a reference, but I know in my class we did the unit circle in the book, and so that's why on the very last page there's a blank unit circle. Oh no, there's a range. Oh no, the formatting's messed up. Domain range is right here. Uh-oh, that's okay, whatever. The range doesn't have to do with this. There's a blank unit circle that we can fill out, and that way you can use this as your notes, and you don't have to go around with like your book page or anything. You can just use this as reference, okay? And so we're going to talk about the points of the unit circle. We're going to fill it out. I'm going to label every single thing. And we're going to talk about sine. We're going to talk about cosine. And then we're also going to talk about tangent, which as I'm recording this, I haven't actually covered this in my class yet. I forgot I was going to be gone on Monday for a field trip. But it's super easy, and I think you'll get the grasp of it, all right? And so let's start. Let's start with where the unit actually comes from, or the unit circle actually comes from, and how do we find these little coordinate points in these angles, okay? And so the first thing I'm going to do, and I'm just going to do this one time. I'm not going to do it all the way around, is just remind you that the unit circle is called the unit circle because the side length, or the radius of each of these little sides of the circle is just length 1. It's just 1 unit. That's where the unit comes from in the unit circle. And so if you draw a circle with a radius of 1, the amount of distance that it takes for you to start here at 0 degrees is what we'll call it. So we'll call this 0 degrees as well as 0 radians. The distance it takes for you to travel around the circle, on the edge of the circle, on the perimeter of the circle, to a specific angle is a radian. So for example, let's look at this first little line right here. Actually, no, let's do this one right here. Let's look at this little angle. Okay. Now this is sort of a bisector between my x and my y axis. And so this angle right here is actually a 45-degree angle, all right? And so we want to figure out how far does it take, if I were a little guy, if I were a little ant on this hill, how long would it take me, how far would I have to travel from this start point all the way around to this point, okay? Well, let's think about it big picture. How long would it take me to travel all the way around the circle? If the radius of this circle is 1 unit, well, we know that the perimeter, or the circumference of a circle, is 2 pi r. 2 times the radius times pi. Well, the radius is just 1, which means that the entire distance around the circle is just 2 pi radians, okay? Which means if I want to go halfway around the circle, if I want to start here and I want to travel halfway to here, that distance is going to be half of 2 pi, which is pi radians. And then if I want to go halfway between 0, where I started, which all the way around is also 2 pi, 0 to this point up here, well, that's half the way to pi. That's pi over 2, okay? And then because I bisected that angle, I made a 45-degree between this 90, that means that this distance from right here to right here is pi over 4 radians. It's half of pi over 2, okay? And so this angle measurement is 45 degrees or pi over 4. They're the same thing, okay? We're going to use them interchangeably. And so that's the first thing that we're going to do is go around the circle and label all of these points, okay? We're going to label all of these angles as they go around. So this is 0 degrees, which is also 0 radians, but it's also 2 pi radians if you go all the way around. This one right here is 30 degrees. Let me do it all in the same color. That way it looks kind of nice. So we'll do red for all the angles. Maybe I'll do blue for the radians. How about that? So this one is pi over 4. This one is pi over 2. This one is pi, and this one is 2 pi. This one at 30 degrees is pi over 6 is how long it would take you. This one here is pi over 3, which was at 60 degrees. Okay. And then we come up to here, pi over 2 is 90 degrees from this angle, right? If I made it, if I started here and I walked around, I'd take 90 degrees. And then we're kind of establishing a pattern. That's how we figure out the rest of these radians, okay? And so what I always remember is that if I'm close to the y-axis, that means I'm going to be over 3. So take a look at this one. This one's close to the y-axis. That's over 3. The same thing happens here. This one's going to be over 3. It's always going to be pi over something. Since this is basically half of pi over 2, and this one down here is 1 pi, all of these little fractions in terms of pi are going to be above a half, but less than 1. And so they're the largest fractions you can make that are over 3, over 4, and over 6 that aren't quite 1. So that means this is essentially 2/3 or 2 pi over 3. This one is 3 pi over 4, and this one is 5 pi over 6. Okay, and the angle measurements of those are 120, 135, and 150. Then if you started here and went all the way around, you made a 180. Okay, and then after you've hit this point in radians, you're now above 1 pi, but not quite. I didn't do this one down here. You're not quite to 3 pi over 2, which is 1.5 pi's, right? In this case, if we're in this little section, this quadrant, all of my fractions are going to end in the same thing. If I'm close to the x-axis, that means I'm going to be over 6. And then if I'm in the middle, I'm over 4. And if I'm close to the y-axis, I'm over 3. And then I'm making the next largest fraction I can make. And so since this is over 6, the next largest thing I can do is 7 pi over 6. This one is 5 pi over 4. And this one is 4 pi over 3. They're just a little bit bigger than 1. Okay. Then we get to 1.5. And now all of these ones in this bottom right quadrant, these are going to be over the same thing. So close to the y-axis is over 3. In the middle is over 4. Close to the x-axis is over 6. And then I'm making a fraction that's almost 2 times the number on the bottom. It's almost 2 pi, but it's not quite. And so all of these are 1 under double the thing on the bottom. So the double of this would be 6. Well, that means it's going to be 5 pi over 3. This one's going to be 7 pi over 4. And this one's going to be 11 pi over 6. Okay? And let me do the angles real quick. These are going to be 210, 225, and 240. This one is at 200 and, oh, I did that on the wrong side. That's okay, whatever. 270 degrees. And then this one is 300 degrees, 315, and 330. And then if you go all the way back around, you're also at 360 degrees. Okay, so that's step number 1 about your unit circle, is where are these degree measurements in terms of radians. And we'll talk a little bit in a second about how to convert from degrees to radians mathematically. Okay, so then the next thing that we have to do is figure out what's going on here in these little coordinate points. What are the values that are going to be at this little x and y spot? Because really, if we're thinking about it, this is on a coordinate grid. This is like on a plane here, right? And so this point out to the right here where we started, well, since the radius of the circle is 1, my x coordinate is going to be at 1, but since I'm still on the y-axis or on the x-axis, my y coordinate is going to be 0. Okay, so this is going to be at 1, 0. This one's going to be at 0, 1. This one's going to be at -1, 0. And then down at the bottom, I'm going to be at 0, -1. Okay, and these are just the x and y point of like where this would be on a coordinate grid. And so now the tricky part is, how do we find these ones? How do we find the ones for the angles, the weird spots? And so here's what we're going to do. I'm going to draw a little point at the thing I'm trying to find, and I'm going to drop a line straight down from it. Okay, like this. So just straight down from it. And then all I'm going to do is make this angle, which is the radius of my circle. this is going to be my hypotenuse, and this leg down here is going to be, or my two other sides of the triangle are going to be my legs of a right triangle. And if I can find this distance, the distance in x and the distance in y in terms of trig, like how would I find them on a right triangle, then I know that this coordinate point's just at the x distance across and the y distance up, okay? And so here's the trick. Here's what we're going to do. We need to know some special right triangle properties about this thing, okay? Now, all of these angles on the unit circle make special right triangles. This one is a 30, 60, 90. So this one is a 30-degree angle. And the relationship of 30, 60, 90 goes like this. The length of this hypotenuse is 1, okay? The smaller side of the right triangle that we make here is always half of the hypotenuse. And so this is going to be 1/2, all right? And then the longer side of this right triangle is always the square root of 3 times the shorter side. And so that means it's going to be the square root of 3 over 2, okay? And that comes from the special right triangle that looks like this. If your small side is x, then the hypotenuse is 2x, and your long side is the square root of 3 times x. It just happens that our x, which really our y, is 1/2. And so that means that this point right here is at 1/2, comma, 3 pi over 2. Sorry, what? Square root of 3 over 2. Okay? That's this coordinate point. And now one thing I want to think about real quick is if I were to find this using a trig function, like if I were to plug it into the calculator, I would have to think about the relationships of sine, cosine, and tangent. We remember that sine is a relationship of the sides of a right triangle that is opposite over hypotenuse. So cosine is the adjacent over the hypotenuse, ca, and t is the opposite over adjacent, which doesn't really matter, okay? Well, if sine is telling me the opposite over hypotenuse, then sine of 30, this angle right here, the opposite side to this angle is 1/2, which is also just our y value, which tells me that on the unit circle, the y value is just going to be the sine of whatever angle we're looking at, call it theta, and the x value is going to be the cosine of whatever angle we're looking at, call it theta, okay? And so I'm going to speed through the rest of them. I'm not going to draw this picture out for every single thing. In fact, I'm going to erase this to kind of make it nice. But we're going to use those properties all the way around the circle. We could do the same thing, okay? And we'll see a pattern that's going to come up, all right? The only one that also is kind of weird is this 45-degree angle. But these 2 points end up being the square root of 2 over 2 and the square root of 2 over 2 because it's making a perfect right triangle where both the sides are the same. Then if I do this point up here, the pi over 3 one, it's a 30, 60, 90 again. So all that happens is that the x and the y get swapped. Oh, I totally messed this up. Oh my gosh. Oh my gosh, I messed it up. I swapped x and y the whole time. X was square root of 3 over 2 and y was 1/2. My bad. Hey, that's my bad. Hey, that's my bad. Hold on. I was still right here. I just flipped them the wrong way. But now I realized because I was about to flip them here and I realized wrong. So now this time the x is 1/2 and the y is the square root of 3 over 2. Okay. And then all of these points are kind of symmetrical, right? It's a circle. And so any point that's on this side is also the same over here, just sometimes negative and sometimes positive. And so this time all of your x values are going to be negative, which means sine is positive over here, but cosine is negative. And this one, sine and cosine are positive. And so it ends up being negative 1/2, negative 1 over 2, comma, square root of 3 over 2. Let me make that a little nicer to look at. Oops. Hello? I've never done that before. I made a circle. Okay, square root of 3 over 2. This one is going to be negative square root of 2 over 2, comma, square root of 2 over 2. And this is going to be negative square root of 3 over 2, comma, 1/2. Then, same pattern continues, except down here, I was going to use green for all of them. Let me replace all these with green so that they look nice, you know. Bear with me, bear with me. Fast forward the next 5 seconds in the video, please. Thank you. Double tap on your screen. Negative square root of 2 over 2. Hey, if you didn't skip the video, here's a secret message. Leave a comment saying what your favorite brand of soap is. Your favorite brand of hand soap. Leave that in the comments. Okay, that was only for the people that didn't rewind. So if you rewind, never mind. Anyway, let's keep going. Negative square root of 3 over 2, comma, negative 1/2. Same sort of pattern here. You see the pattern and the points are the same. All you're memorizing really are these things. You only have to memorize square root of 3 over 2, 1/2, and square root of 2 over 2. You just need to remember where they place, okay? And then this is negative square root of 2 over 2, negative square root of 2 over 2. Both of them are negative down here. This one is negative 1/2. This is negative square root of 3 over 2. This one's at 0, negative 1. And then x is positive, y is negative down here. So negative y, but the same points going around. Okay, cool, cool. And so that is pretty much what you need for the unit circle, but we're going to add one more thing, which is tangent, okay? Tangent, and I'll do that in purple. So tangent is, once again, opposite over adjacent. However, the hypotenuse is 1 because all of the radius of the circle is 1. And so that means that sine basically just means opposite, and cosine basically just means adjacent, which means that tangent is just sine divided by cosine, okay? Whatever you plug in for tangent, it's always just sine divided by cosine. Tangent of theta is just sine of theta divided by cosine of theta, okay? And so to find the tangent of these angles, which I'll do on the outside here, all you have to do is divide the y thing divided by the x thing, okay? And so what that turns into for this point is 1/2 divided by square root of 3 over 2. You flip this, you do this, you cancel everything, and you end up with the square root of 3 over 3. That's what goes here, the square root of 3 over 3. Because it's, I don't know, 1/2 times 2 over the square root of 3, because you're multiplying by the reciprocal. These cancel, you get 1 over the square root of 3, and then you rationalize the denominator and make it square root of 3 over 3. So that's that. Then this one is just 1, because square root of 2 over 2 divided by square root of 2 over 2 is just something divided by itself. And then this one is square root of 3 over 2 times 2 over 1, because you're dividing by a fraction, so you're multiplying reciprocal. These cancel, and you just get square root of 3. And so the tangent of this one is square root of 3. And then everything's the same, except down here, all of these are negative. So this is going to be negative square root of 3. This is going to be negative 1, and this is going to be negative square root of 3 over 3. These ones, because it's a negative divided by a negative, you get a positive, and so it's square root of 3 over 3 positive, positive 1, and square root of 3. And then over here, it's going to be back to where we were, but negative. And so now it's negative square root of 3, negative 1, and negative square root of 3 over 3. Okay? And so that's almost all the points, but we still have these 4 that we started with, the 4 sort of coordinate directions that I have. And so we got to think about what's going on here if I divide y by x, because that's what I'm doing to find tangent. Well, this is just 0 divided by 1, which is 0. This same thing over here, 0 divided by negative 1 is still 0. But then, what about these? This one becomes 1 divided by 0. And as we remember, we can't divide it by 0, and so it's undefined at that point. And so we'll just call this undefined. And so it's this, undefined. And now we have a fully completed unit circle. How sick is that, dude? That's amazing. It's so cool. Completed unit circle. This, in and of itself, if you copy this down, this should carry you through the first page, maybe even the first 2 pages of this test, right? We have these problems. We have these ones, which actually kind of need something for these. And then all of these. These are all just points on your unit circle go around and find them, right? You just find these values. So these are just looking at your unit circle and finding them. Okay, so I'm actually not going to do any of these because I labeled all of them. I'm also not going to do these because you can just find them from a unit circle, except maybe this one. I'll talk about 8 pi over 3 for a second. Let me go back to this. So 8 pi over 3 is not on the unit circle, but think about it like this. If I were to make one full rotation, if I went all the way around the unit circle back to where I started and then just moved up a little bit, then I'd be at the same place. I'd be at the same value. I'd just be one full rotation later. And so I can spin around the circle as many times as I want. As long as I end up at one of these places again, I'm at the same value. Okay, so it's cyclical, right? It revolves around. And so really what you got to think about is for this 8 pi over 6 one, 8 pi over 3, how many times did you go around in the circle before just arriving at that next point? Okay, so figure out how many times did we do a 2 pi revolution, take that away from this fraction, and then figure out what's left, and then find from there. Okay, cool. That's tricky, but you can do it. All right, the only other things that we don't maybe use the unit circle for are these two, which is converting from degrees to radians and radians to degrees. I'm just going to give you the little formula here, okay? And so we know that 180 degrees equals pi radians. That's because if we go halfway around the circle, we've traveled pi radians, which is 180 degrees. And so if I'm converting from degrees to radians, all I got to do is say degrees times, so you take your degree amount, whatever you're plugging in, and you multiply it by pi divided by 180, and you get what you want, okay? So you plug in your degrees, such as 190, and then you multiply it by pi divided by 180, and then I would normally write this as like 19 over 18 pi. I just kind of reduce this fraction and then put pi in it next to it, okay? That's all I would do. And then for these ones, for radians to degrees, similarly, you plug in your radians, the radians that you have, and you multiply by 180 divided by pi. And so in this case, you'd end up with 22 pi over 3 times 180 over pi. Your pi's are always going to cancel out, and then you're really just evaluating this. What's 22 times 180 divided by 3? And then figure that out. Okay, so that's how you use those two. These ones you use the unit circle. For these ones, you do what we just did, convert from radians to degrees and vice versa, normalize it, right? So get it on the same page. Either pick degrees or radians to put them all in and then sort them. And then these ones, look at your unit circle, find the values at those points and sort them that way. Okay. All right, now to the second part of the test. The big part after the unit circle is graphing sine and cosine. Okay, so I'm going to write the steps out here. I'm going to do a few examples of each. I think we're going to call it a day. I think that's all we got to do. Okay, and so first thing I'm going to do is draw the transformation form of sine and cosine, okay? And so we look like this. So I guess step one would be find the key features. And they come from this. Y equals, or f of x equals, whatever you want, a times, sorry, I'll just say a sine of b times theta minus c, shoop, shoop, and then plus d. And the same thing is true for cosine. So it's just y equals a cosine of b times theta minus c plus d. Okay. And what do these things mean? Well, A is our amplitude. That is the distance from the midline of your graph to the top and bottom. So if my sine looks like this, my amplitude is either this distance from middle to top or this distance from middle to bottom. Okay. B tells us about the period. because we use it to find period. The period is how long it takes for you to do one full cycle. Sine looks like this with one full cycle. You start and end at the same place, and then you go up, and then you loop down and come back up. The period is always, this is supposed to be an arrow. The period is always 2 pi over b, okay? C is your phase shift, as we call it, which is just a horizontal transformation. That means left slash right. However, in the equation, it's inside the parentheses. That means left is actually when you subtract, right is when you add. It's opposite what we might think. And then D is your vertical shift, which is also where your midline is at, slash midline. And that is up and down. And this one follows the rules. Up is plus, down is minus. Okay, wait, I totally messed this up. Left is plus, right is minus. Duh. Duh. Everyone knows that adding is left and subtracting is right, dude. Everyone knows that. Okay, that's not even the steps, but you know, that's what you need. And so here are the steps. Here's what I would do. Step 1 is plot your midline. That's your vertical shift, basically how high or low it's at. And then step 2 is to plot your amplitude, meaning how high or low above the graph is it going to go. Plot your amplitude. And then step 3 would be plot start and end points. You always start and end at the same place. For sine, you start in the middle and end at the middle. Okay. I would say step 4 is to plot your, I'll call them halfway points. Your halfway point of your period is in the middle directly on the midline. And then you go up and down. Okay. And then step 5 is if you have a phase shift, shift those points. At least that's the way I like to do it. A phase shift move them. Okay. And so sine always looks like this. You go start in the middle, end in the middle, and then you go up and down for positive sign. If you flipped A, if you made A negative, you go down and then up and around. Cosine, however, is a little bit different. Cosine looks like this. If this is the start and the end of our period, then halfway we're at the bottom, and then 1/4 and 3/4 of the way we're at our middle. So cosine goes like this. All right, let's do an example. Let's do a couple examples. So I'll pick 2 of these graphs to do. I'll do, let's do this one and this one. How about that? Okay. No, I'll do this one and this one. Okay. So first things first, we have to find our key features. The amplitude is 1/2. So that means on this graph, it's going to be a little weird. We're going to go half a box up and half a box down. Okay. Our period is always 2 pi over b. Since b is nothing, like there's no value multiplying theta, such as this is a b value, my period is just going to be 2 pi. Okay. My phase shift is going to be plus pi over 4. Plus is actually to the left, and so that's going to be left pi over 4. And then my vertical shift is down 1. Okay. I don't care about start point, to be honest. And so, yeah. So first thing I would do is plot the vertical shift. I would go down 1. And so I'm going to make a line, a dashed line at -1. That's going to be my midline. That's where I'm going to sort of revolve around. Okay. Then next step is to plot the amplitude. It's 1/2. And so I have to do a little dashed line half the way up the box and half the way down the box. That's awful. My bad. But, you know, sometimes you got to do the tricky business, dude. You know, you got to do the 1/2 every once in a while. Oh my God, it's so bad. You know what I'm gonna do? Actually, check this out. Check this out. They don't teach you this in teaching school, dude. I'm gonna go here. No, I'm gonna go here. I'm gonna go thin. I'm gonna make it dotted. I'm gonna make it green, and I'm gonna go like that, dude. And then I'm gonna snag you. I'm gonna click you. I'm gonna right click you. I'm gonna say copy, and then I'm gonna right click, and I'm gonna paste it, and then I'm gonna drag you down here. And then what I'm gonna do, and this is the craziest part, I'm gonna actually do the same thing. Make it red. Oh no! Oh, sorry, my bad. Hold on. I gotta do this. I gotta do this. I gotta make it red, and I'm gonna make it a little dash, and I'm gonna go in between. I'm gonna move the entire page. I'm gonna go. What did it? Hold on. It's actually really easy to do this. I'm really fast at it too. Okay, I'm really cool and quick with it. I just gotta. Yes, sir. That's a little too thick. Make them less thick. There we go. Sick. Look at that, dude. That's nice. And so you can do that on your own paper, by the way. All you got to do is follow those instructions that I did. Change the settings around on your pencil. Okay, then we're going to plot the start points and the end points of our period. That means we start at 0. And so on my midlines, I'm at 0. And then at 2 pi, I'm also back to where I started. And then halfway between, I'm also in the middle. Then, because it's sine, I go up, down, and then up. And so I'm going to plot a point at pi over 2, a quarter of the way up, and then a quarter of the way down. And I kind of see my pattern, okay? But I have a phase shift, right? I have a phase shift. It says left pi over 4. Now, what I like to do is take these points now and move them pi over 4, each individually, and then kind of erase as I go. If I look at the scale of my graph, it shows me that every 4 boxes is pi. And so that means one box right here is pi over 4. And so all I have to do is take each of these points and move them pi over 4 to the left. And so I'm taking all my old points and shifting them one box to the right. Damn, look at all my STEAM friends, dude. That guy Connor, he was in my high school math class with me. I wonder, I should text him and tell him that I'm recording a video for me teaching the Algebra 2 class that we had together, teaching him how to graph functions, and he's popping up in my video. He doesn't know he's about to be YouTube famous, dog. All right, and that's it. Look at that. Isn't that cool? We've graphed it. We've shifted it. It's a weird graph, but I graphed sort of a period and a half. It looks good. It looks nice. I like it. And so the last thing you have to tackle is domain and range. Well, what's cool about these is domain is all real numbers. I mean, I go everywhere, left to right. This thing doesn't stop. It goes on forever like this. The range, though, I actually kind of like it for these ones. It's always just the bottom value, your bottom asymptote. It's not really an asymptote. It's like a boundary. Your bottom boundary to the top boundary, which is just, in this case, half below -1 and half above -1. Well, that's just -1.5 to 0.5, -0.5. Right? And I'm using these brackets to be inclusive. I can actually touch these boundary points, right? I'm actually hitting those points, and so we use the bracket to say I can be equal there. I can include that point, okay? Math is all about being inclusive, except when it's not. Okay, let's do this one. Here we go. I'm almost done. How long has it been? Has it been like an hour? How long has it been? I feel like I'm quick. Oh, it's only been 33 minutes. Oh, come on. Let's go. Okay, so let's do this one. Same thing, same process. Let's find all the key features. A value is my amplitude. It's 2. Whoa, hold on. It's 2, okay? B, B is 1/2. Ooh, my period is 1/2. That means that it's 2 pi divided by B, which is 2 pi divided by 1/2. Well, when we divide by a fraction, that's the same as multiplying by the reciprocal, or the flipped version of that fraction. And so it'll be 2 pi times 2 over 1, which is 4 pi. So my whole period is 4 pi. That means I'm going to start and end at 0 and 4 pi. Okay. My phase shift is going to be left pi, because it says plus pi right here. So left pi. Note that this b value doesn't affect it as long as it's outside the parentheses here. In pre-calc, you're going to do some trickier ones where they won't separate it. They won't put the b value outside the parentheses. You have to factor it out. In this class, we're a little bit nicer, okay? And then my vertical shift is down 2, which is also my midline. So let's do that first. Let's do my midline at -2. I'm going to change my pencil settings again. Once again, you just have to click these buttons on your pencil, and it'll do it for you. So don't worry about drawing a straight line. It'll just do it for you. Oops, I chose the wrong color. Let me just change the color real quick. And then I have to go up 2 and down 2 from there. That's my amplitude. And so let's do this. Let's do this. Actually, you know what? Let me just copy this. I think if I had to have a superpower, I honestly don't think I would choose anything like super life-changing. Like, I feel like I would abuse my power. Like, with great power becomes great responsibility. Everyone knows that. I think I would be irresponsible, to say the least. Like, I think I would be very irresponsible with my power. And so I think if I had a superpower, I would probably choose to be able to cut and paste, like copy and paste things on paper, you know? Like, if I was like writing in pencil, I would just want to and I would want to just be able to like click that and copy and paste it. I think that's what I would choose. Like, I think that would save me so much time. That would be so convenient. And it would also be super cool party trick. Like, you could write on a piece of paper, or you could do a deck of card thing, and you could be like, sign the deck of cards. You sign the deck of cards. You get the cards back. You shuffle them up, whatever. And then you pull out some random card, and then you copy and paste their signature onto that card. And you're like, was this your card? And it's like, well, how did your signature get on it? Anyway, maybe that's what David Blaine does. Maybe he has that power. Anyway, okay. So we've plotted my midline and my amplitudes. Now we got to plot my start points and my end points. Since this is cosine, I know the shape of my graph goes like this. And so I start and end at the top. And so I'm going to put a point at 0 at the top and at 4 pi, because remember my period was 4 pi because we found the b value and we did all that. And so we start and end 0 and 4 pi, which means halfway I'm at my bottom. I'm at my lowest, which is at 2 pi. And then a quarter of the way through at pi and 3 pi in this case, I'm in my midline. Okay. So I sort of see the pattern here. I see it emerging. But remember, we had a phase shift. It said left pi. And so I'm just going to take each of these points and I'm going to drag them pi to the left, which if I look at my bounds, pi is every 2 boxes in this case. And so I'm just going to take these points and move them like this. This one's going to kind of go off the graph. And then I'll erase everything that I didn't have before. This one was here, though. And then I'll draw my graph. Like that. That was really bad, actually. That was not good. But there you go. It's not too bad. It's not bad. Okay. And then domain and range for this one. Let's end off. Domains, all real numbers. Nice. Range is -4 to 0, bottom to top. So -4, 0. And then we can be inclusive with it because we can touch those points. All right. I'm going to leave the rest for you to figure out and do by yourself. This problem right here is kind of cool. Write a sine function with an amplitude of 3, a phase shift of pi over 3 to the left, and a vertical shift up to 4. Just use your transformation form of equation like this and making a little equation, talk about the domain and range. Okay. And so big things I want you to have for this review. You can use this review as notes. You can graph these 4 if you want. If you need help, you can talk to me in person. But really, I want you to have this unit circle down no matter what. Honestly, if you have this unit circle down and you know what it means, you know how to read it, and you can just think about it as points on a coordinate plane, I mean, that'll carry you through not only this test, but like a major chunk of pre-calc. In fact, today, as I'm recording, this is the AP pre-calc test. I went into one of the classrooms and helped some of the kids study. Well, I didn't really help them study. I just kind of annoyed them and talked to them. But one of them was doing like a problem that I was like, oh, we were doing this right now. It was like, find this point on the unit circle. And I was like, well, hopefully you can do that. And so, yeah, I really think if there's anything that you memorize in your mathematical career, the best bang for your buck is the unit circle. I mean, it carries you through so many things. It carries you through calculus, calc 1, calc 2, calc 3. If you do any calculus behind that too, it'll carry you there. So yeah, this unit circle is super important. Anyway, that's it. Bye.